Hello everyone. In the last session, we have started the magnetism and we have seen about the Biosavart law, and we have also started calculating the magnetic field due to the current carrying wire, and we have calculated the magnetic field and we got a formula that mu naught I upon 4 pi d into sin theta 1 plus sin theta 2, where theta 1 and theta 2 are taken in the anti-clockwise direction from the perpendicular distance point, and the d is defined as a perpendicular distance from the wire. And then we have solved some examples for the practice, and now we are going to proceed our discussion further. So let us start. Okay, so now as we have in the electrostat, we have seen the two cases. So here we will also see the two cases. One is a uh, semi-infinite wire, semi-infinite wire, and another one we will see infinite long wire, infinite long wire, correct? These are the two things we will see this, and we will discuss about this. Okay, so for, and then we in middle we will see the finite length wire, finite length wire. This is a conclusion page for you. Okay, finite length wire. See, if I am preparing the short notes for you also, okay, and still you are like, what you are doing, you are not seeing the video, you are not liking it, nothing you are doing. Like, we are doing so much hard work for you, but you people don't show a respect to anything. We are doing our work. Okay, so semi-infinite wire means finite length wire and infinite length wire. What is the formula for this all three cases? Semi-infinite means this end is closed and this end is going to infinity. Clear? In that case, suppose the current is like this and the distance simple, same, d is their distance. In that point, magnetic field will be inside, correct? And formula is, what is the formula? Mu naught I upon, mu naught I upon, see, theta 1 will be how much? You tell me, what is theta 1? Theta 1 will be here 90 degree, and theta 2 will be here how much? What is theta 2? What is theta 2? My question is, what is theta 2? My question is, what is theta 2? Correct? What is theta 2? Theta 2 will be 0 degree. So what is the formula? The formula is very simple. That is defined as mu naught I upon 4 pi d. Direction is inside. For a finite length wire, we have calculated the formula. What is the formula we have calculated for a finite length wire? If suppose the distance is d, suppose the distance is d, and this angle is theta 1 and this angle is theta 2. What is the value we have calculated? Theta 1, theta 2. Remember this, they are in anti-clockwise direction. The distance is d from here to here, correct? And magnetic field will be inside, that I told you. And what is the value we have got? The value is very simple, mu naught I upon 4 pi d into sin theta 1 into sin theta 2. That is the formula we have got. For in this case, the both is going to infinity. So obviously, what is my theta 1? That is equal to 90 degree. And what is my theta 2? Theta 2 is also equal to 90 degree. So when you put this value in this equation, what is this is my general equation, correct? This is my general equation. Na? Put theta 1 equal to 90, theta 2 is equal to 90. This will become 2. So what is the value you will get? Suppose this distance is d and I want to know the value at this point, and the magnetic, sorry, okay, so magnetic field at this point will be how much? Mu naught I by 2 pi d, correct? This is the thing you have to remember. This is a complete conclusion page for you for all the three types of wires. Okay, it will be very clear what is the formula for all these three. Clear? Just note it down. First, completed. Okay, let's move to the one example. Let us start with the example. Okay. The example is, suppose, let's do some example. Suppose there is a sheet is there, infinite sheet, okay, infinite long sheet, or infinite long sheet is there. Means sorry, okay, correct. This is an infinite long sheet. This distance is d. It is not looking like a d, but it is d. Okay, the distance is d, and the current is I is flowing in. Okay, the current I is flowing in this. Correct. Total current is basically in this. Basically, we have a current I here. Simple. Just remember this current I. Basically, what I am asking to you, I am asking to calculate from the center. This is its center. From this center, I am asking at a distance L. What is the magnetic field at this point? Simple question. Okay. What is the magnetic field at this point? That is my simple question I am asking. Okay. That is my simple question at this point. What we will do? What is your approach to solve this? See, the approach is very simple. Approach is very simple. What you will do? You will break it into a smaller wires, and then you integrate it. That is a simple approach. So what I will do, first I will take a small element. It is a straight element, but I'm not able to draw it straight perfectly, but it is a straight small element is there, correct? The thickness of this element is dx, and what is the current? The current is di, which is defined as I by d into dx. Means in capital D thickness we have a current I. So in a small dx thickness this will be the current, correct? By unitary method. So what is my magnetic field? See, we will write the smallest magnetic field dB. It is by the wire, na? So what is the magnetic field due to the wire? It is infinite. So it is mu naught. I means di upon 4 pi into d. D is the distance from this is suppose x. So d means x. Now you just put the value mu naught I by capital D into dx divided by 4 pi, correct, into x. This will become how much? Mu naught I by 4 pi capital D into dx divided by x. And what is it? How, from where you have to integrate? From which point to which point? You tell me. You have to tell me the limit of integration. My question is, you have to tell me the limit of integration. What is the limit of integration? From where you have to integrate, from which point to which point? Tell me. You have to integrate from this point to this point, correct? So what is my integration limit? L minus d by 2 to L plus d by 2. Yes or no? Array, you have to integrate from this point to this point. So L minus d by 2 to L plus d by 2. Correct? Yes or no? Array, say something, yes or no. Correct? Now integrate this. So what you will get? Mu naught upon 4 pi d ln L plus d by 2 L minus d by 2. Correct? And what is the direction? Thumb in the direction of current, curl, it is inside. The direction is inside, so this value will come inside. Are you getting my point? So this type of question we can take. Okay. So what is the value? Mu naught I upon 4 pi d into ln L plus d by 2 divided by L minus d by 2. Clear? Any doubt? Clear? Okay. Let's take some more example. I have taken some like hard example. Let's take for the this type of question generally asked in the NEET. Okay, I hope NEET is student can solve this, because generally this type of question they ask in the NEET exams. Next example. Let us considered we have a one wire, okay, or we can take like this. Suppose this is a wire, it's coming like this, and then from this point it is going like this, correct? From where it is coming? It is coming from infinity. It's going up to infinity. Clear? The picture is very clear. What I am saying, from its perpendicular bisector. This is my perpendicular bisector, correct? This point is, suppose this point I have given to you. Okay, the distance from here to here is d, and this whole angle is alpha, and this is at angle bisector. Okay, at angle bisector. Okay, this current is I, this current is also I want to know the magnetic field at this point. Okay, can you calculate the magnetic field at this point? Yeah, it is visible. Okay, so how will you do? How will you calculate the magnetic field at this point? What is the approach? Okay, let's go for the approach. The simple rule. First, it is a infinite or semi-infinite. It is a semi-infinite. What is first? What is the first term? Perpendicular distance. This is my perpendicular distance. This is angle bisector. So this angle will be how much? Alpha by 2. Correct. This is 90 degree. Correct. No problem. This will be what? 90 minus alpha by 2. So first is what is theta 1. Theta 1 will be go up to infinity. So theta 1 is 90 degree. What is theta 2? Sir, it will be 90 minus alpha by 2. Correct. Sir, what is d? Can you tell me, sir? Sir, d cos theta and d sin theta. So it will be d, or sorry, or you can say like my distance will be how much? D sin alpha by 2. Okay. So what is my net magnetic field? These three value we will get. So what is my net magnetic B1? B1. I am writing due to this wire. Okay. This is suppose first wire. This is suppose second wire. Correct. These are the two wires are there. Okay. This is due to this is first wire. Suppose. So B1 I am writing mu naught I upon 4 pi d. D is how much? A sin alpha by 2 into 1 plus, because sin 90 is 1 and sin 90 minus alpha by 2 is cos alpha by 2, correct? Cos alpha by 2. So this value will become how much? Mu naught I upon 4 pi a into sin of alpha by 2. 1 plus cos alpha by 2 is how much? That is 2 sin, it is 2 cos square alpha by 2. Yeah, sorry, first there is some mistake we have done. Yeah, sorry, this is the mistake. Yeah, now it is correct. Or just leave this like this only, no issue. 1 plus cos alpha by 2, we will figure out this later. Basically this is my B1. Now you tell me, due to this wire we will get the same thing, correct? Yes or no? Because this will be again what? This is alpha by 2, this is 90, correct? So this will be alpha minus 90 minus alpha by 2. So you will get the same magnetic field due to this also. So can I just do one thing? Just multiply by 2. Why? Because the direction is also same. See, the direction is inside for this and the direction is inside for this also. So just I can multiply it by 2. So I will get my B net. this will become my B net. I am multiplying it by 2. So this will become mu naught I upon pi into A into sine alpha by 2 into 1 plus cos alpha by 2, and this the whole value is inside. This whole value I am getting is inside. Okay, clear? Is this is clear to you? Clear? Okay, let us take some let us do one exercise. It's not a question, it's basically a question to get a one solution. A question to get a one solution. We are going to do a one question that is going to give you a one solution. Clear? So let us do that. Let us do that question so that we can get a one solution. So basically, let us consider, okay, let us consider what we have to consider, sir. So let us consider. Let us consider what we have to consider. Let us consider we have a wire, correct, whose length is given as 2 pi r, correct. The length is 2 pi r and it is folded into a n sided polygon. It is converted to n side polygon. Now question is, let us do this. First let us do this, okay. So basically I have a wire, it has a some current, okay, and the length of this wire is given as 2 pi r, okay. I have converted into a n-sided polygon, so let us convert into a n-side polygon. So this will be some one side. Let me draw it very straight. Correct. Correct. So this is the thing. Then what is the length of one side? 2 pi r n divided by n, correct. 2 pi r divided by n. This is the length of one side, correct. Any doubt? Okay. So suppose the center, and this is going up to infinity like this, correct. It will go up to like this, okay. Suppose the center is here. This is my center, okay. Then okay, if this is a center, I can join this to this point and I can join this also with this point, correct. And suppose this is my angle bisector, correct. First you tell me what is the total angle. What is the total angle here? This angle, total angle. The total angle is 2 pi. If it will form a complete, it will be a 2 pi. 2 pi, how many sides are there? N. So total angle will be 2 pi by n. Now what is this half angle? The half angle will be pi by n, and this is also pi by, correct. Suppose this distance I am saying d. Now what I am trying to ask you, I am asking you what is the magnetic field due to this single element I. I'm not talking about other element, just you tell me the magnetic field due to this element. So if I am writing the magnetic field due to this element, okay, if I am writing a magnetic field due to this element, what is the value of this? My question is, what is the value of this magnetic field? It will be simply mu naught. First, it is a finite length or infinite length? It is a finite length, okay. Mu naught I upon 4 pi. What is d? D is the this distance, correct. D will be this distance. This is my d. Now what is the value? See, this distance, you know, this is pi by pi r by n, because angle bisector na, so it will divide into two equal parts. This distance I know, this distance I want to know, this distance. So what is the approach I will do? I will write tan theta that is 10 pi by n is equal to, that is pi r by n into d. So d value will be how much? Pi r by n into quad pi by n, correct? This value I will get. Any doubt till here? No doubt. So this is my d. Okay, now what is the formula? Sin pi by n plus sin pi by n, that is 2 sin pi by n, correct? So what is the value I am getting? Mu naught I by 4 pi, this is become a 2 into sin pi by n, correct, into pi r into n into, this will become cot pi by n, this is cot pi by n. Clear till here? Anyone have a doubt? Till here anyone have a doubt? Just I put the value, I haven't done anything. Now if I just solve this everything, what I will get? See, total value I am calculating, so I will multiply it by n also, because there are n side. Clear or not? I will multiply it n with n, because why I have multiplied with n, sir? Because there are n side, na? There are how many sides are there? There are n side. I will just multiply it with the n, correct? I will multiply it with the n because there are n sides are there. I will multiply it with the n. So if I multiply it with the n, can you tell me what is the value you will get? If you just solve this, you will solve this, you will get mu naught for calculating the net, v net. V net will be how much? N into mu naught n I divided by c, 2 pi, this is pi r, okay, n, one more n is there, that is going into numerator. I'm just putting into the numerator, correct? This is sin pi by n into how much? 10 pi by n. So that is my net value I am getting. If I am not wrong, I am just doing a very small change, okay? Just I am writing in a different manner. Just see it here how I am writing. I am writing as mu naught I upon 2 into r, and I am doing a small change. I am writing like this: sin pi by n divided by pi by n, correct, and into, just a minute, into 10 pi by n divided by pi by n, correct? Is there is any doubt till here? Anyone, any step you have a doubt, you can tell me. I have just applied the mathematical formula and just done the geometry. Till here anyone have a doubt in this equation? I have just written into this form. Clear? Any doubt here? This is the one observation we are doing, okay? I will tell you the conclusion, but here anyone have a doubt till here? No one doubt? Okay, just note it down. Clear? Okay, so let's proceed further. So we have got as b net is equal to how much? Because everyone will have a direction inside only, so b net, this is inside, okay? What is the value we have got? We have got, that is mu naught I by 2r. Remember, it is r is a radius, okay? R is a radius, 2r into how much? Sin pi by n divided by pi by n into 10 pi by n divided by pi by n, okay? If n tends to infinity, if I am making the n is equal tends to infinity, then this geometry will convert it into what? If n will tends to infinity, this will convert it into what? What is the shape of this? Can you tell me? If it is converted into, if n is tends to infinity, then it will behave as a, it will then polygon will converts to circle, and polygon will converts to circle. So what is my b net in this case? If you have a knowledge of limit, if n tends to infinity, this value will become 1, this value will become 1, and the formula will you will get is mu naught I upon 2r in the internal side. Simple. That is a simple formula. So let me give you the conclusion. What is the conclusion? You have to remember the conclusion is very simple for you. This I have just given you a concept that from where it is came. There is another method to derive this, but I am going with this concept because it is more, give a more idea, more practical idea how it is coming. Okay, that's why I am going with this method. So suppose this is my circular wire and the current is in this direction. How will you find the direction? In this case, what you can do, what is the approach? That keep your thumb in this direction and curl your finger, correct? But I am telling you one more method. Just curl your hand in this direction and see your thumb. That is also you can do, or you can do keep your thumb in this direction and curl your finger, okay, at the center. This is, I am talking about at the center, because this is a magnetic field we have calculated at the center now. So this is also at the center only, okay, at center. Let me write this as a center, otherwise most of people will confuse. Okay, so at center, what is a magnetic field? Outside. So you will get magnetic field outside. And what is the value of that magnetic field at the center? It is very simple, mu naught I upon 2r. Suppose the radius is r. Clear? This is the conclusion you have to remember for this. Any doubt? If you have any doubt, please let me know. So that is a magnetic field due to a what? Due to a circular ring, or you can say circular wire, whatever you can say. This is a circular ring, you can say. This is a circular ring only. Circular ring, but at the center. Remember that circular ring at center. I am calculating at center. I am not calculating at the axis. Remember this thing. Okay, it is at the center. So if I ask you one question, I think you can answer me. Or I will give you. See, this is clear. Now let write a give a small heading. Basically, I am preparing everything for your question solving. Give a small heading. Suppose I have some random shape. Okay, it can be anything. Like in the electric field, we have derived the formula similarly here also. Suppose I have some random shape. I don't know what is the shape. Okay, suppose the shape is some random. Okay, it can be any angle theta. In that case, we have to calculate the magnetic field. What is the approach? How will you do? How will you calculate the magnetic field due to this? Suppose the current in this is I. What we will do? We will take a small element d. Okay, and we will bring it to the center. Suppose this is d theta. Okay, this is dl. Okay, so what is my magnetic field? I will write mu naught, current is I. What is the formula I will write? Mu naught I. This will behave as a small what? Like what I have to write? Can you tell me? Biosavart law, simple Biosavart law apply. Now mu naught I upon 4 pi. What is the distance? This distance is radius is r square into dl into what is the angle? Sine theta. How much is the sine theta? If you see, my dl vector is like this and my r vector is like this, correct? What is the angle between them? 90. So sine 90 degree. Okay, so if you put to calculate the total value, what you will do? You will integrate, correct? You will integrate. So when you integrate, you will get mu naught I upon 4 pi r square integration of dl. From dl is integrated from 0 to how much? Like from where to where? What is the length of this arc? What is the length of this arc? That is theta r, correct? So what is the value you will get? Mu naught I upon 4 pi r into theta. That is a general formula for a magnetic field. And what is the direction for this? Curl your finger in the direction of current and the thumb will, or you can say this inside. Okay, so this is the inside you are getting. Remember this is a general formula, and where theta is what? Theta is in radian. Theta is in radian. So for a circle, if it is a circle, can you tell me what is the value of theta for the circle? It is 2 pi. Just keep it here 2 pi. Pi will cancel out, 2 will cancel out, you will get this formula only. So that is a general formula. This is a general formula. Okay, this is a general formula. General formula for any type of ring, or like for any type of circular arc. Okay, for any type of arc, any, what is the any, for any arc, any arc. Okay. I can ask you for the quarter also similar. If so, if by using this formula, if I ask you, let me ask you, okay, so let me ask you for let me, okay, so let us take an example. Let me ask you for a, for what? Okay, so let me ask you for, okay, suppose this is hemisphere. It is a hemisphere, not, it is a half circular ring. It is a half circular ring and the current is going like this, half circular ring. Okay, so what is the magnetic field for this? What is the magnetic field for this at the center? Obviously at the center. Okay, so what is the value? Mu naught I upon, formula is 4 pi and the radius is given r. Okay, r into theta. What is the theta value for this? This is pi, just put it here, you will get how much? Mu naught I upon 4r. What is the direction? Inside. Never forget to tell the direction, okay, because it is a vector quantity. Magnetic field is a scalar or vector quantity? Vector quantity. Field is always a vector quantity. Okay, I haven't written, let me write, otherwise some people will say, oh sir, you haven't written it. Remember, right, this is a vector quantity. Okay, clear? Sorry, what we are discussing? Yeah, so what we have seen the magnetic field due to the wire, we have seen the magnetic field due to the circular ring at the center, that is mu naught I upon 2r. We have seen the magnetic field due to the hemisphere. We have seen the general formula also, means I can give you this also, that I can give you this also. See, I can give you this thing also. I can give you like this also, and suppose this angle I have given to some 120 degree, then how will you find the magnetic field? Same formula, magnetic field at the center is equal to mu naught I upon 4 pi, sorry, 4 pi, 4 pi into r. What is the theta? You will write 120 degree, but 120 degree should be written in radian, so it is 2 pi by 3. So what is the value you will get? Mu naught I upon 2 into 3r, correct? So that will become how much? Mu naught I upon 6r. But what is the direction? Curl your finger, or you can say put your thumb in the direction of current, curl it, so it is coming inside, so this will be inside. Simple. So like that I can ask anything to you. Okay, so let's do some good question. Okay, let's do some questions. Okay, The question is very simple. Um, Suppose this is x, y will be z. Okay, let me check it once. Okay, question is very simple. What we are saying that okay, this is a hemisphere. The current is going like this. Okay, the current is going like this. The current is going like this. This is I, this is also I, this is also I. Okay, and this point, this is given as A. I'm not giving the point. And my question is very simple. What is the question? That at this point, okay, what is the net magnetic field? This point, B net. Okay, B net. How will you write? What is the answer? Remember, I am asking B net, not the magnitude. I am asking the vector. I am asking the vector. So what is the approach? See, we have a three element. We have one wire, we have a one hemisphere, and we have another wire. This is what? Semi-infinite or infinite? Obviously semi-infinite, because one end is solved. So what is the approach you will do? What is your approach? See, this wire is going, so it will be inside only. Okay, it will be inside only, correct? So I will write due to this wire first. So how will you do? Just write it separately by every wire. So this is mu naught I upon 4 pi A. The distance is A. And what is the direction? See, if you can see properly, it is going like what I'm trying to say. See, this is my x, this is my y, and this is my z. Okay, this is my z. Are you getting my point? Means x, you can see from here. This is my corner. Suppose this is x, this is y, this is z, and there is a wire across this. So what is the magnetic field? It will go down only, na? It will go down like this. Correct? Are you getting my point? Are the magnetic field will go down only, na? Are this is a y. Okay, the wire is like this, so magnetic field will be like this. We know that, but at this point, what is the magnetic field direction? Downward only. So this is minus j. What is what? Minus k cap. Correct? What is the magnetic field due to this wire? Again same. Again it will be what? At this point, see, at this point the magnetic field due to this is downward. At this point the magnetic field due to this will be what? It will be how much? See, current you have to, and it is going inside. Inside means y axis minus y. That is, what is the value? Mu naught I upon 4 what? 4a. Correct? And what is the direction? That is minus j cap. Correct? Now what due to this wire, if I calculate, it is also inside. Inside means mu naught I upon 4 pi a, and that is minus k cap. So when you do this, you will get mu naught I upon 2 pi, correct? 2 pi into a minus k cap plus mu naught I upon 4a into minus j cap. That is the answer. Here, this is how you can write the net magnetic field due to this. Clear? So now I can give any geometry, any type of configuration to you. It doesn't matter. Okay, I can give anything. Let's take one more example. You can take like this also. Suppose this is two wires are there. You can make anything. Okay, this is the wire. The current is going from this direction, and it is like this. Everything is given. At this point I want to calculate the magnetic field. This distance is r. What is the value? Simple. Just write the value for tax. Fast write this value. Due to this wire, what is the magnetic field? And due to this wire, direction will be inside only. Overall direction will be inside. You know this same question. It will be mu naught I upon c. What is the value? 2 pi r. Okay, plus inside this I have added together. Okay, then mu naught I upon 4r. Correct. Inside this is also inside. Correct. Both are inside only. So what is the net value you will get? V net magnitude you will get how much? Both are inside, just add them together. Mu naught I upon 2r, take common. So how much you will get? From here you will get 1 by pi, and from here you will get 1 by 2, and that is inside. That is a net value. Clear? So this is how you can do. Like, you can take any geometry. One more geometry is also there. If you want, I can take this is the geometry you can take. Let's consider this one circle, one bigger circle inside this. Okay, and then what you can do, okay, so this is the, you can say, two hemispheres are there. Correct. And they are joined together like this. Wow. Correct. Any doubt? So this current is, sorry, this current is I, this current is also I, this current is also I, this current is also I. Suppose this is my center C, the radius is R1 and this radius is R2. My simple question is magnetic field at the center C. Simple question. What is the magnetic field at the center C? Calculate. Just I give you 30 seconds. Tell me the answer. What is the magnetic field at the center C? First you tell me what are the different parts are there. See, you can see this is the one part, this is the another half semi, this is the one small length, this is the one small. 4 elements are there. Okay, correct. These are the 4 elements. By one every element you have to calculate, then you have to add up, and then you have to tell me the answer. That is a simple approach. Clear? Use your brain. Fast. Hello. Okay. See, first tell me, due to this, what is the magnetic field? In net value we have to calculate. No? Magnitude we are talking about. Okay. Magnitude. So what is the, due to this one? So this will be mu naught I upon, what is, 4r, correct, r2, and obviously inside you calculate the direction. Then due to this one, what is mu naught I upon 4 r1 inside only, correct. Now what about this and this one? First, you tell me what is the magnetic field due to this point. Theta 1 is how much? 0. Theta 2 is how much? Okay, leave this. What is the formula for what is the formula of Biosavart law? Biosavart law states that the net magnetic field at the magnetic field due to a small circuit element dl is defined as mu naught I upon 4 pi into dl cross r divided by mod of r cube, or you can say it is mu naught I into dl sin theta divided by r square into 4 pi. Now you tell me what is the theta here? That is a formula, na? You remember? This is the formula. What is the theta? Theta is the angle between the dl vector and r vector, correct? R position vector. What is the r position vector here? This is my r position vector. This is my r position vector, correct? This is my dl vector. What is the angle between dl and r? 0 degree. That means this quantity will become 0. This sin theta will be 0. So whole magnetic field will be 0. Getting? That is the thing. So whenever, remember, this type of case will come lot of times. So I have given you the reason. I have given you the reason or explanation how it is getting 0, because generally the people don't give. Okay, so the reason is very simple, because it is along the line. The element is lying along the line where you have to find the magnetic field. So theta will be obviously 0. So in this case, the answer is 0, but due to this 2, correct? So what is the net value you will get? Mu naught I upon 4 into 1 upon r1 plus 1 upon r2. Don't, r1 r2 is not a resistance, it is a radius inside point, correct? Now I want to give you one homework question. Please note it down. I know everyone can solve this. There are a lot of solutions are given on the internet, you will get, but it is better if you try to solve it by your own. Okay, try to solve it by your own. Very simple, like it's a previous year question. Basically what they have said, we have taken a wire and we have start like winding it closely. Okay, we are winding it like this we have done. Okay, like this, and the current is going like this. The inner radius, the smallest inner radius, let me draw it properly. Basically what we have seen, from suppose this is my starting point, like this we are rotating. Oh sorry, like this. Suppose we are rotating like this. Okay, this is my center point. Inner radius is given as A, the outer radius is given as B, and the current direction is obviously like this. Okay, or anywhere, like you can assume like this. So magnetic field, it is clear that magnetic field will be at this point, will be outside. Okay, no problem. Total number of turns is n. Total number of, this is total turn. How much? Total turn. This is the total number of turns. Total turns is n. My question is, what is the magnetic field at this point? Center point C. A simple question is, what is the magnetic field at this point? It is a very famous previous year question, but I want you to solve it without using any type of help. Just try to give your effort and try to solve it, because when you fight with a question, then you learn about the things. Then you will revise all this thing. Okay, you revise all this thing and then you will learn about all these things. So it is better you have to do the fight. So first fight for the question. Okay, so just try to fight it and just try to get the answer for this. Okay, okay, clear? Any doubt? So in this session we have learned about a lot of things, and we have learned about a lot of things. We have seen a lot of illustrations on the different types of cases. In the next session we are going to calculate the magnetic field on the axis of the ring. We have seen the center, We have seen any circular ring, but any type of part of the circular arc, but we haven't seen at the axis. Okay, so we will see the magnetic field at the axis of the ring, and then we will move toward the properties of the magnetic field line. So it is better you just go for the next session. It is better you just go and revise the properties of electric field line. It is somewhat similar to it. So because see, this syllabus is going to, now the chapter is going to be little fast. Now I am going to be little fast. Why? Because in the electrostatics I have covered the most of the concept which is going to be come into the future. Okay, so that's why I am going to be little fast. So you have to now start revising the things, and now the things will be more like more practical. Okay, so it's very important to do the proper revision, and we will bring the strategy shown. We will on mostly on the Sunday you will get a one video where we will tell you how to do the proper study and how to do the proper revision, because the most problem thing is how to do the revision while reading the present things. So that is the thing. We will discuss the proper strategy for scoring a 180 out of 180 in the physics. That I will discuss, and I will tell you how to do that. Okay, so till then, take care, goodbye, and if you have liked this session, please like it, share it, and subscribe it. Have a nice day. Thank you.